Assalamu alaikum and a very good afternoon. In today's class of SMJC4513 Atmosphere Pollution Control and Engineering, I'll be presenting about atmospheric dispersion modeling. Before going on with the subtopics in this chapter, I will describe the definition that I found for this topic. The first definition that can define this atmospheric dispersion modeling is that atmospheric dispersion modeling is a mathematical simulation of how air pollutants transport, transfer, and disperse in atmosphere. It is a manual calculation of how air pollution is being three ways, which is transport, transform, and disperse in atmosphere. Furthermore, another definition that can describe this modeling is it is a mathematical or statistical means the observed phenomena of pollutants being diluted and dispersed in open atmosphere. Atmospheric dispersion modeling helps us to understand how pollutants are behaving in the open atmosphere. Physical explanation of atmospheric dispersion is that streams of pollutants release into open atmosphere and rise. The stream bend over and travel with wind mean which dilute the pollutants. Plume of pollutants will spread out and disperse in horizontal and vertical directions from the center line. In atmospheric dispersion modeling, we'll be using the Gaussian model for our calculation. So what is the Gaussian model? The Gaussian model is a model to describe the dilution of the contaminated gas stream in both horizontal and vertical direction. In the Gaussian model, there are several assumptions that have been made for us to better understand how the pollutants behave. Firstly, atmospheric stability is uniform throughout the layer into which contaminated gas stream is discharged. Secondly, dilution of contaminated gas stream in both horizontal and vertical direction due to turbulent diffusion is a random activity. Thirdly, contaminated gas stream released into atmosphere at distance above ground level is equal to the physical stack height and plumb rise. Degree of dilution of effluent plume is inversely proportional to wind speed. So if the wind speed increase, the degree of the dilution of the plume will decrease because the relationship between both is inversely proportional. And lastly, pollutant that reaches ground level is totally reflected back to the atmosphere. In the Gaussian model, here is the plumb dispersion coordinate system where the pollutants are dispersed from a virtual point source where usually it is described as stack that are widely found in the industry. As described in physical explanation, the plume of pollutants will spread out and disperse in both horizontal and vertical direction as be described in the diagram where we have the x, y, and z plane to simulate how the plume travel. In the Gaussian model, there are several equations that are being used for our calculation. In the Gaussian model, we can calculate the plumb rise delta H. Delta H can be calculated by using the equation in this slide where delta H is equals to Vd over U, where V is the stack velocity, D is the stack diameter, and U is the wind speed. Furthermore, we need the parameters such as the stack temperature, air temperature, pressure, and wind speed. Please be reminded that the temperature must be in the unit Kelvin. Furthermore, we can also calculate the downwind concentration ground level in the unit gram per meter cube. From this slide, From equation 1218 showed, we can calculate downwind concentration in the unit gram per meter cube. Some parameter in this equation such as the Plum standard deviation Sy and Sz are constant parameters that can be obtained, which will be explained in the next slide. As mentioned in the assumption, value of effective stack height capital H is equal to the sum of physical stack height small letter h and the plumb rise delta H. To calculate downwind concentration of equation 1218, we need values for plumb standard deviation Sy and Sz. The plumb standard deviation Sy for horizontal and Sz ever vertical can be obtained by determining the distance downwind in km. The distance downwind also will provide the class stability, whether the stability is the class of A, B, or C, D, or E. Referring to the equation in the slide, the equation is ground level centerline concentration calculation. As observed from this equation, the concentration at any point x decreases very quickly as the h increases. So the relationship between the h and x is inversely proportional. Tall stack. Tall stack can be defined as the stack that is tall more than 2.5 times as tall as the tallest nearest building. The stack gas that released from the stack has high buoyancy. The stack gas exit velocity is expected to have more than 1.5 maximum average wind, and the large emission rates of more than 10 megawatt. Next is plumb rise. Why plumb rise and travels in certain direction? As plumb moves away from the stacks, the vertical momentum decreases due to the drag and entrainment of air. The plumb bends over the direction of the mean wind. The buoyancy is still impacted, causing the plumb to rise for a longer period. So from the picture on the left side, the brown tall pole is the stack, and the plumb which travels in the wind mean direction, in which is the white in color, is the plumb. In addition to the Gaussian model for us to calculate delta H, we can also calculate plumb rise from the empirical and theoretical methods in the slides. We can calculate delta H by using many methods exists by determining the value of QH in megawatt. For example, there are Holland plumb rise models. Here are the equations involved. And furthermore, there are Briggs plumb rise model to calculate the plumb rise. Here we can calculate the plumb rise delta H and also the buoyancy flux term FB in Briggs plumb rise model. Next is critical wind speed. Plumb rise is inversely proportional to U. U is the wind speed. So the relationship between delta H and U is inversely proportional. The exponential term increases with increasing U. Maximum Cmax exists at some wind speed U. Thus, type of speed is called critical wind speed. A plot of Cmax against wind speed U is plotted. Trace the smooth curve passing through the maximum. The critical wind speed depends on the stability and the specific plumb rise model. Here is how you determine the critical wind speed. Plumb downwash. Plumb downwash is happen where there are low pressure being created behind a structure. Is a disturbance in a flow system. When designing a stack, there are some consideration. Here are some consideration when designing a stack. Specifying stack diameter small enough to make the exit velocity 1.5 times the maximum expected sustained wind speed. Secondly, flat disk is located circumferentially at the stack top. And lastly, the disk diameter to be equal to 3 times the stack top diameter. In stack dispersion modeling, there are computer programmings for us to calculate the stack dispersion modeling using software. Computer programs for dispersion modeling can be purchased from National Technical Information Service (NTIS). It can be downloaded from EPA's Electronic Bulletin Board. US EPA has developed Gaussian-based computer program. For example, Mobile 6 or MOVES can calculate emission factor for fleet average emission factor for any particular set of variables. Moving on, which is the mobile source method. Mobile source is emitted from vehicles such as lorry, trucks, motorcycles, and vans. They, as we know, vehicles emit large amount of carbon monoxide, NOx, nitrogen dioxide or nitrogen monoxide, and volatile organic chemicals VOC. Pollutants emissions are vary due to the type of driving, the pollution control equipment available in the vehicles, and the degree of maintenance of the vehicles. Mobile source method is a model to model the vehicle emission rate, fleet average emission factor. Line source dispersion modeling can be described from this figure 20.16, the finite length line source FLLS model. Line source dispersion model is a continuation of fleet average emission factor from the mobile source method, where we can observe from this line source dispersion modeling, the x-axis is parallel with winds and passes through the receptor, y-axis is collinear and perpendicular to the wind. That's all is for our atmospheric dispersion modeling. In conclusion, atmospheric dispersion modeling is a technique to evaluate the pollutants dispersion. It is important for us to calculate atmospheric dispersion modeling for to ensure the society and public places are not impacted with the pollutants emitted from the industry areas. The importance to keep the emitted air safe and clean and impacted positively for our clean and better environment. Thank you very much for your attention. Assalamualaikum.